Okay, let's finish this off with SL paper 2. But I'm only going to go through the ones that weren't covered in the HL paper 2, which is surprisingly not very many questions. So let's see. Might as well get started. Here's question number 1. Jane claims that rabbits in Australia have longer ears than rabbits in Spain. Okay. Australian median was 80. Interquartile range is 11. The recorded values for the Spanish rabbit ears are below. Complete the following table for the recorded values and lengths of rabbit ears in each sample. Okay, sure. Where's my pen? Here it is. So they told you with numbers the median and interquartile range of Australia's lengths, and then they give you a box and whisker plot. So of course you should know that this middle line right here is a median, represents the median. So what the heck is this? I think this is like 75. And the ends of the boxes are the first quartile and the third quartile. Of course, the median is the second quartile. And then, of course, IQR. This is just from Q3 to Q1. So we're just going to take Q3 minus Q1. It's kind of ugly. And then what are these? 84, 68. I don't know why I said 84. 88, 68. So IQR is 20. Okay. And then, how's that 3 marks? Whatever. Justifying your answers, compare the distributions and the lengths of the rabbit ears in Australia and Spain using the median. Wait, what am I? I'm just supposed to wait. Justify what? My answers or Janie's answers? Okay, let's pretend you're trying to justify Janie's claim or justify your claim that she's wrong. So she says that Australia rabbits have longer ears than rabbits in Spain. So if you were to use the median, then that's true. So you could say something like, you know, since the median of Australia's is more than Spain's. Do they have the same amount? They don't tell you how many are in each sample. But the median represents the halfway point. So what that means is that half of the rabbits that were measured in Australia were long, their ears were longer than 80, compared to half of the rabbits in Spain whose ears would be larger than 75, the upper half. So I guess like if you use the median, Australia does have longer ears, like the upper 50%, compared to the ones in Spain. And then you also need to use the interquartile range. So you can see here the spread of Australia's is tighter, so they're closer towards the median than compared to Spain. Spain has a larger interquartile range, so they're spread more out, which means that here, let's just draw a little box and whisker plot. So 11 is the IQR for Australia, so 5.5. So about 74 to like 86. So this is the range of ear lengths for Australia. It's closer to 80 because the interquartile range is 11 compared to Spain's. And then, I don't know why I'm drawing this because it's just the box and whisker plot. 65, 95. So if you were to compare this part right here, right? So 25% of the rabbit population in Australia is between this ear length range compared to 25% of Spain's. Because this is from Q2 to Q1, so this is 25% of the population. And you can see that if these were of equal sizes, their populations, then there are larger ears in this 25%, and then that also means in the future 25% beyond Q3. So you can say like, yeah, because this one's spread out more, then that means that you have like larger ear sizes. Oh, more rabbits are further away from 75 than Australia's. I don't know, whatever. Such a weird question. Usually they ask you more like, I don't know, calculating based ones, like find out what's the smallest number you need to be an outlier. But yeah, you can say something like that, I'm pretty sure, and they'll take it. It's like 4 marks, 2 marks each, right? Okay, and then I skip all the way to number 7. So what that means is, in the HL video of mine, I cover the rest of the short answers in paper 2 and SL. So for example, this question about the car, this is number 2 in the SL, it's number 1 in the HL. Right, this cone one is number 3. This random variable one is number 4. This sine wave one is number 5. This regression one is one of the long answer ones that I'll be skipping. So we skip all the way down to number 7. Yeah. Okay. We have a function here. And then we need to show that this is the inverse. Okay? There's various ways that you can show this. One thing you can do is you can solve for the inverse. And then you just show that when you do that, you end up with this. You can also show that their compositions will return an X. So you can also check this. I think the easiest thing to do would be to just solve for the inverse, because that's probably something that you would have done in like a practice question. So we can set f of x to be y if you need to. And then you are going to rearrange this equation and solve for x. Some people and teachers, they tell you to switch x and y first, and then you solve for the new y. It's the same functionally speaking. So I'm just gonna solve for x and then switch it at the end. So let's see. You're gonna multiply by 2/3. Because this is 3/2. So we multiply by the reciprocal. And then once you're here, this is an exponential. And if you ever need to isolate something in the exponent of an exponential, you change this to log form. So this is essentially saying that x minus 2, the exponent, is equal to natural log, because this is base e, of 2y over 3. And then from there, we just add 2, and then we get what we want to show. Here. Oh yeah, and then you switch x and y, right? But yeah. Okay. Okay, these intersect at P and Q, shown on the diagram. And then find PQ. What do they mean by find? Like, find the length of PQ? Like, find the length of this line? Do they want me to find an equation for PQ? I don't know what they want. I'm gonna assume that they want you to find the length of PQ. So, to do that, right, this is just Pythagoras. We just need to find the coordinates of P and Q, subtract their x values and square them, and then subtract their y values and square them. And because this is paper 2, and because I know the equations of both functions, we can just graph both functions and find the coordinates of their intersection. So that's what I'm gonna do on Desmos. So the first one was what? 3 over 2 e to the power of x minus 2. So there's f. And then the other one was 2 plus natural log of 3x over 2. Oh wait, this needs to be in the exponent. Don't be difficult, Desmos. There we go. Okay, so here's your first point of intersection, and there's your second point. So let me just screenshot this. And then yeah, we follow the formula, right? You can call this x2, y2, you can call this x1, y1. Order doesn't really matter. And then calculator. I mean, if you watched a lot of my videos by now, you know, like, I hate paper 2s. Because it's just like ugly numbers and like calculator work. And I don't think that's that fun. Okay, so we want to do x2, so 2.832, this one, minus x1, 0.113, so this is squared, plus the difference between the y values, 3.446 minus 0.227, square this, and then square root it. And here's a little tip. In most scientific calculators, the square root button, you need to do at least 2 button presses. You gotta do like second, and then you press square root. I personally think it's a lot faster to just do to the power of 1/2 or 0.5. But that's just me. Okay, 4.21. I guess. If this is what they want. I have no idea what the heck they want. Find PQ. Like, what about PQ? Okay. Let's see. The graph of f is reflected in the x-axis and then translated parallel to the y-axis by 5 units in a positive direction to give the graph of function g. Write down an expression for g of x. Okay, so we have function transformations, right? We have a reflection in the x-axis, and then this is such a weird way to phrase a vertical translation. Parallel to the y-axis 5 units in the positive direction means you want to move it up 5 spaces. So, in other words, right, if you're, this is like the kind of general format of a function transformation. So this is d is plus 5, and then a reflection in the x-axis basically means that a is going to be -1. We don't have a b or a c because we don't have a reflection in the y-axis, so this is just 1, and we do not have a translation parallel to the x-axis. Such a stupid way to say it. We don't move it left or right, so that's 0. Okay, and then write an expression for g. In other words, g of x is, what the heck was f? -2/3 e to the x minus 2 plus 5. Right, we add a plus 5 at the end that moves everything up 5 spaces. And wait. Oh wait, there's an order to this. Oh, but the order is fine. Yeah, reflection first and then translation. So reflect by making it negative and then moving it up 5 spaces. And then what is the domain of G? Doesn't... Why are they asking you this? Okay. For the domain of G, it's based off of the domain of f. So f is an exponential, right? It's an exponential function. So those either go like this, or they decay and they go like this. But regardless, their domain is going to be all real numbers. So if we have a reflection in the x-axis, that will not change our domain. It just makes our graphs flip over and upside down. And also moving it up or down doesn't change our domain either. So I can just show you on Desmos. So this one, right? So as you can see, my domain is all real numbers. If I reflect this in the x-axis, then it's still, my domain is still all real numbers. And then of course if I move it up 5 spaces, then all I did was just move it up 5 spaces. My domain's still all real numbers. So here you go, domain of G, same as domain of F. Solve the equation. Let me just move this one out of the way. So now we equate F and G. Give your answer in the form x equals a plus natural log b, sure. Okay, so now we're gonna equate the two. So 2/3 e to the x minus 2 is equal to, that's F, negative 2/3 e to the x minus 2 plus 5. Okay, now because they want your x in a specific format, this is an exact value. There's no equation solver for this one, unfortunately. Okay, so what should we do? We are going to collect our x's or our terms with x's together. So I'm going to move this one over here. And then these are like terms essentially, so it's just like 2/3 plus another 2/3 of this thing. So 2/3 plus 2/3 is 4/3. This is equal to 5. And then, you know, we're gonna multiply by the reciprocal of 4/3. So I'm gonna multiply 5 by 3/4. So this is 15/4. And then we're solving for x, so just like before, we change this into log form. So 15/4 is equal to natural log, or wait, hold on, other way around. X is equal to natural log 15/4. And then we're done, right? Yeah. We don't have an a value, but that's fine. 0 is a rational number. B is a rational number, so 15/4 is fine. We're not looking for a whole number or an integer. And then, yeah, you're done. Let me do a quick gut check here. And I'm gonna graph the two against each other. So this is where they intersect, 2.511. So I'm just gonna see if the natural log of 15/4 is the same thing. And if it's not, then I messed up somewhere. Damn, I messed up. Wait, oh, these are supposed to be 2/3. Hold on. Will that change it? I mean, not enough. I'm supposed to get 3.322, so where did I go wrong? Oh no, it is 3/2. Oh, shoot, then that's... Okay, hold on. These should have been 3/2. Okay, sorry. 3/2, 3/2, 3/2, 3, 3/5/3. Oh, I forgot the -2 as well. Okay. So 5/3 plus 2. There we go. Sorry. Right? Half of 3 plus another half of 3 is a full 3. Divided by 3. Then log form. And then there's going to be an x minus 2. And then we add the 2. Okay, sorry. I think this is good. So let's just double check that. 5/3. And then what was it? Plus 2? There you go. So this value is correct because it goes through where they intersect. Okie dokie. That was a short answer one, right? No, it was a long answer one. And yeah, there is no question number 8. This is number 7. Number 8 is the regression question. So go watch that. Keep in mind, I mentioned it in another video afterwards, but I do mess up the regression question because I put the numbers in wrong. So that's why it doesn't work out for me. But the explanation is right. So listen to the explanation. Okay. Farmer, wall, triangle wall, farm thing. Okay, here's our diagram. Find the two possible sizes of OAB. So we're trying to find angle OAB, which is this angle right here. Giving your answer in degrees. Okay, so the way that this is set up, we can use sine law. The way that I teach the kids to recognize sine law is that sine law is essentially, the setup is you need to know a pair. So a pair is its angle and the length of its opposite side. And if you have this, then you can use sine law to solve for anything else in the triangle as long as you have one more piece of information. So I call it like you can use sine law to complete another pair. So in this case, I can find out what this angle is here and complete this pair. If I have this pair, I can find this pair. Or I can, yeah, complete this pair. Now, one thing that they do note is that they emphasize possible, because when you are using sine law to solve for an angle, there is the ambiguous case, which means that you could have two possible angles for B. So that's what we need to keep an eye out for, but that's fine. So we are actually going to find angle B first. So sine of B divided by 50 is equal to sine of 28 divided by 25. So we can multiply the 50 over, and essentially this means that if we want to find the angle B, we're going to take the inverse sine of 50 times sine 28 divided by 25. Okay, and then just make sure you're in degrees. So inverse sine, and then let's see, 50 divided by 25 is 2, so this is just 2 times sine 28. And we get 69.9. B, angle B. Okay, so if this is one of our answers for angle B, then we can now find out what the third angle is. This is actually the angle that we want. And we know that they sum to 180 altogether. So I can just add this to 28 and then subtract that from 180. So our first answer for angle OAB in red is 82.1. Okay. Then we need to find the second answer. And the second answer is the ambiguous case. Because, you know, I didn't go through the whole exam and I have some time, let me just explain the ambiguous case of sine law for you. Okay, maybe essentially what happens is when you have a sine law setup, certain measurements are fixed in place because that's what the question told you. In our example, we had 25, 50, and 28, right? So I'm just gonna redraw the triangle. So I know that this has to be 28 degrees because the triangles, the question said it was. I also know that one of the lengths attached to 28 is 50 meters. So I'm going to draw that as this one up here. So this is fixed length. And then I know the length of the opposite side to 28, which is 25. So I know for sure that this has to be 25, right? Now, the issue with this is that it doesn't say anything about how long this side is or how long this side is. So as long as this length stays 25, there could be two possible triangles that satisfy the conditions for our sine law. So we could have this triangle here, and as long as this stays the same length, you can move this around wherever you want to. Now obviously if I move it out, I can't make a triangle like this because remember, this has to be 28 degrees. So this line is not going to connect with the third length if it was like this. So this is a triangle. And then if you do your sine law will always give you the acute answer. So now I know that this angle right here is 60, let's just call it 70. So we use sine law. And we know that this is 70 because we know that this is 25. But like I said, only the things in blue have to stay what they are. So this has to stay 50, this has to stay 28, and this has to stay 25. But what you can do is you can swing and move the 25 length over to here, and you see I still have a 28 degree angle here. This is still 50, and this length is still 25. So there is an ambiguous case because there's two triangles that satisfy sine law. So what we need to do is we need to find out what this angle is here. That's the second angle. But because of like geometry, these two lengths are the same. Which means that I know that this angle is the same as the first answer for sine law. It's also 70. And then that means that this obtuse angle, which is the second possible angle, it's just 180 degrees minus the first answer that we got from using sine law. So then, let's call this angle B1. angle B2 is just the complement, or the supplement. 180 minus 69.9. And then this is whatever it is, like 100 point something. $110.1. Why can't I change my pen? Okay. Okay. So there you go, right? That's kind of ambiguous case explained. There is one little thing, right? If the way that your sine law is set up, and this is long, then you might only have one triangle. So like, let's say that this wasn't 25, instead it was like, I don't know, 70, 100 or something, right? Yes, we can do sine law, and we know for sure there's at least one answer in this situation. However, if you try to swing it over, you need to go past... You need to go past this line. And so what happens is you break the triangle. So there is actually no second angle when that happens. So remember, like this can be whatever you want, this angle. So as long as this is short enough that you still have room when you bring it over here, you can make another angle here and make a second triangle, that's fine. But if this is too long, then you run out of angle to use to create a second triangle, and then there's only technically one answer. So it's pretty easy to check whether or not you do have a second triangle. And that's when you find your second possibility, right? 110. You add it with the angle that they give you. And then you just see if you have enough room for this angle here. And the way you have enough room is is seeing that, is this over 180 or not? So if I added these two angles together, our second obtuse angle from the ambiguous case and the angle 28 degrees, that is well below 180, which means that I do have some angles to use and make the third angle and make the third triangle. If your second answer from sine law plus the angle that they give you in the answer or in the question, if this is over 180, then that means that you don't have a second triangle. That means that this line, this length was too long. You could only make one triangle. You run out of room, you run out of angle to swing it over here. There's also another case that you don't really need to worry too much about, and that's if this is too short. If this is too short, then you can't even touch this line and make a triangle. If that's the case, then you have no solution, there is no triangle, but that's pretty evident when you use the inverse. If you use the inverse and an error pops up, then that essentially means you don't have a triangle at all. There's no solution. Anyways, back to this. We're not quite done. So we just found out that we have an ambiguous case, and this angle up here has two possibilities. So what that means is that our second angle here also has two possibilities depending on the green one. So $110.1, we're going to add that to 28. And then if I subtract 180 degrees, this is our second possible angle for the red one, 41.9. And don't get this confused. A lot of students think that like, oh, this angle has a second possibility because of sine law. So then what they do is they take like 180 and then they subtract this angle. So they have the right idea, right? You're supposed to subtract, to get the second angle, you're supposed to subtract the first angle you find out from 180. But that's for the angle that you use sine law on, this green one. To find the second angle for the red one, you just select the second angle from sine law, and then you just remember that these three angles are 180 degrees together. Kind of a weird mistake. I've seen it happen, so I'm just pointing that out. Anyways, hence find the two possible areas of the triangular field. Wonderful. Okay. So area is easy. This is just 1/2 AB sine theta. Or sine C, I guess. So what you do is you just... The setup is you need to have side angle side to use this formula. This is also the setup for cosine law. If you want to find the third side, you need to know two sides and the angle in between. And that's what we do know now, right? 25, 50, and then we know the two possible angles in between those two sides. Okay, so 1/2 times 50 times 25 times sine 82.1. So there's your first answer, 619 meters squared. Or the second one, which is the same numbers except for the angle. So let's just go back, copy this, delete these, and put in 41.9. So that's 417. Okay. And then let's see. One of the goats, Brenda. There's goats in this question? I guess I didn't read it. Okay. Is fights with the other goats. Farmer plans to place a second fence with a fixed length of 10 meters, like here, between the wall and the hedge. And then this makes a smaller triangle inside of the bigger triangle for Brenda. Oh, okay. Brenda's got to be separated. The small triangular field OCD has an area of 60 meters squared. Okay. Let X be the distance OC. So this is X. And OD is Y. Then we need to show that this equation is true. Okay. So this equation, we'll get this somehow. But essentially, we're gonna probably use the fact that we know that this area is 60. We're gonna manipulate it, and it'll probably end up something like this. But okay, let's get that out of the way first. Area 60. I know that this is 1/2 50, or not 50, X times Y. Sine 28 degrees. Oh, and then I know this is 10. Okay, I know where we're going. So if you're not sure, try to see if like this equation they want you to show is familiar in any way. And at least the x squared y squared should be, given this setup. This is essentially cosine law, right? We have side, angle, side. So then we can use cosine law and say that 10 squared which is 100, that's looking good, is equal to, you know, x squared plus y squared minus 2xy times cosine 28. Okay, I see where they're going. So this is what we got from the area. And then from cosine law, you know that 10 squared is equal to x squared plus y squared minus 2xy cosine 28. All right. And then if you notice, this is our 100. This is our xy. Xy is by itself, so we're gonna move this term over to the other side. And then we're also gonna flip left and right sides of the equation. And we need this. We currently have this. And then this is why they tell you the area. What we're gonna do is we're gonna make a substitution. And we're gonna make a little fancy substitution and we're gonna solve for xy because xy shows up in the cosine law here. So using the area formula, I'm gonna multiply the 2 and then divide by sine 28. So this is gonna eventually become 120 divided by sine 28 is equal to xy. Okay. So this goes in here now. So you get x squared plus y squared is equal to 100 minus 2 times 120 over sine 28 cosine 28 like that. And then 2 times 120 is 240. And then cosine, right, divided by sine, if we're speaking in SL terms, that's the same as dividing by tan 28. So again, here, let me write it like this. So we put our trig ratios together. And then as an SL, you guys know that sine divided by cosine is tan. And then this is just the reciprocal. So if you know your fraction, multiplication, and division, this is the same as dividing by the reciprocal. Usually we use it the other way around. To divide a fraction, we flip it and multiply it, but we can reverse it like this. And then now we know that this is tan. And then you get the answer here. Obviously, there's more elegant ways to explain it or understand it, especially in HL, because this is literally just cotangent, or and then cotangent is literally the reciprocal of tan. Or even from here in SL might be able to see, this is a reciprocal of tan, and this is a reciprocal of tan, because it's in the denominator. Okay. Hence, determine the lengths, 2 possible lengths of OC. OC is x, right? So I need to solve for x. And the problem right now is I have a y, so I can't solve for x until I get rid of it somehow. And I think what we're gonna do is we're gonna use the fact that this area, we know the equation for this area. Actually, let me just start from here. OC is X, right? Yeah. Okay, we are gonna do another substitution, except strictly with Y. So in other words, Y is equal to 120 over... I guess I'll write the X in front. X times 928. I'm just gonna divide the X. And then this is gonna substitute for Y in here so that I will have an equation that's just X. And we are basically done. How do you solve this equation? Algebraically? I have no idea. Actually, kind of I know, but you don't need to worry about that because this is a paper 2. And we can put it into an equation solver and it will just tell you the answer because it's a paper 2. So let's go here. I want to solve, what was it? X squared plus 120 over sine 28 times X. Squared. This is equal to 100 minus 240 divided by tan 28. Yeah, sure. Alright. Do your magic. Results. Give me the approximates. Complex numbers? What? Did I mess something up? This is in degrees, yeah. X squared, Y squared, this is Y. Oh, it's plus 240. Whoops. There we go. Plus, plus, plus. Okay, two possible lengths. So yeah, plus minus, obviously the x has to represent a length, so we're gonna ignore the negative ones. 13.1, 19.5. Okay, bada bing, bada boom. We're done. Not bad. I think... just like paper 1, it's pretty straightforward. There's like obviously a question or two that might be difficult, like this one right here. But overall, I think the exams this year for Time Zone C, which is the Americas, was pretty on the easier side. Even the HL level questions, paper 1, paper 2 didn't matter. Pretty easy. And then I've heard from browsing the Reddit, it was pretty easy for the other time zones too, because your papers got leaked. And I don't know if IB has issued a statement saying whether or not they're gonna do something about it, but yeah. Alright, that's M23 time zone C. I do not have access to the other time zones for those that keep asking me, because I formerly worked as an IB math teacher in time zone C Americas. So I have connections to those papers sooner than when IB publishes them, because I get a copy. If you can somehow get me that copy, sure. Then I can go over the other time zones, but it's fine. I barely check the email for this anyways, for this account. So yeah, thank you for watching. Send this to some M24s, my channel. I've been monetized. So give me some ad revenue, give me some ad watch, some ad views. And yeah, see you guys later.